Hi, this is lesson 10.1, Apply the Counting Principle. Our big question here is how do you determine the number of distinguishable permutations in the letters of a word? So by the time we're done with this lesson, you should be able to answer that question. So let's look at our frames. Our key topic here, applying the counting principle, is about figuring out the number of ways events can occur. So we're figuring out the number of ways events can occur. And our so what, down here at the bottom, let's fill this in while we're looking at this part of the frame, is you simply multiply how many times each thing can occur with the fundamental counting principle. So the fundamental counting principle is what we'll be talking about. It just tells us multiply how many ways each event can occur. So the fundamental counting principle with two events. If one event can occur m ways and another event can occur n ways, then the number of ways that both events can occur is m times n. So you just multiply the number of ways for both things together. So if I have 3 or more events, the fundamental counting principle can be extended to 3 or more events. For example, if there are 3 events occur in m, n, and p ways, then the number of ways all 3 events can occur is m times n times p. So here's our first example. You're buying a pizza. You have a choice of 3 crust, 4 cheeses, 5 meat toppings, and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose? So how I like to do these is I like to make blanks for each choice. I have 1 crust, so I'm going to put a blank for that, times I can pick 1 cheese, times I can pick 1 meat, times, and then I can pick 1 vegetable. So for my first choice, how many crusts, I have 3 options. For my second choice, how many cheeses, I have 4 options. For how many meats, I have 5 options. And then for how many vegetables, I have 8 options. So if you just go through and multiply those all together, you're going to get 480. So there's 480 different ways you could do this. For B, if pizza crust is not a choice, how many different pizzas could be made? So if we eliminate the pizza crust, we're going to first have an option for our cheese. Then we're also going to have to choose a meat. And then we're also going to have to choose a vegetable. So we still have 4 options for our cheese, 5 for our meat, and 8 for our vegetable. And if you multiply those together, you get 160. Example 2, use the fundamental counting principle with repetition. So a town has telephone numbers that all begin with 329 followed by 4 digits. How many different phone numbers are possible if A, the numbers can be repeated, so that's what repetition means, is you can repeat something, or B, the numbers cannot be repeated. So for A, I'm going to have 4 blanks because there's 4 digits in the phone number. And if numbers can be repeated, well, my digits that are possible, you can have 0 to 9. So that's 10 options. So for my first number, I have 10 choices to choose from. If I can repeat numbers, then I still have 10 choices for my second number, 10 choices for my third, and 10 choices for my fourth. So if you multiply those all together, you get 10,000. Now let's talk about B, where numbers cannot be repeated. So I'm still going to have to make 4 choices. I'm still going to draw my 4 blanks. For my first choice, I have 10 options. Since I've used 1, for my second choice, I only have 9 options. I then have 8 for my third choice and 7 for my fourth. And if you multiply those together, you get 5,040. So it makes a difference whether or not you can repeat numbers. So let's flip this over and look at the other side of your frame. So now we're talking about permutations. This is about how we find the number of ways we can order objects. The key thing here is we're talking about how we want to order objects. So with your so what down at the bottom, with permutations, order matters. This is very important to remember whenever you're talking about a permutation. The order matters. And if you're doing a word problem, you should start asking yourself, does the order matter for this one? And if the order matters, you're going to use permutations. So this first main idea is permutations of n objects taken r at a time, and this is without repetition. So the number of permutations of r objects taken from a group of n distinct objects is denoted by NPR. So NPR you can simplify like this. It's n factorial divided by n minus r factorial. And just if you need a reminder of factorial and what that means, if I had 3 factorial, that would mean 3 times 2 times 1. If I had, let's say 10 factorial, that'd be 10 times 9 times 8, so on, all the way down to times 1. So that's just where you multiply that number together. And you should have this button on your calculator. It's under the PRB button, the probability button. So you'll have that on there. So our first example. So you have 6 homework assignments to complete over the weekend. So we've got 6 assignments. That right there is our N. But you only have time to complete 4 of them on Saturday. And how many orders can you complete 4 of the assignments? So 4 assignments is what I want, and that is my R. So we're going to do 6P4. So that is 6 factorial over 6 minus 4 factorial. So 6 factorial over 6 minus 4 is 2 factorial. So I'm just going to write this out. You could put it in your calculator at this point, but I want to show you a little bit more so you understand a little better here. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. 2 factorial would be 2 times 1. Now notice I've got some of the same numbers on the top and bottom. They're all multiplied. So these 2's I can cancel and these 1's I can cancel. So this really is just 6 times 5 times 4 times 3. And if you multiply that together, you get 360. So our next example, I suggest you pause the video at this point and try this one on your own. Okay, welcome back. You're left a list of 9 chores to finish, and how many orders can you complete? 5 chores. So 9 is my N and 5 is my R. So we want 9P5. So that's 9 factorial over 9 minus 5 factorial. So that's really 9 factorial over 9 minus 5 is 4 factorial. So I'm just going to write this out again so that you get the chance to understand what this really means. It's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And if we cancel out, these cancel. So this is really 9 times 8 times 7 times 6 times 5, which if you multiplied that together, it's 15,120. So now we're going to do permutations with repetition. So the number of distinguishable permutations in n objects where one object is repeated s sub 1 times, another is repeated s sub 2 times, and so on is this. It's this formula right here. So n is our number of objects. S is how many times one of the things is repeated. So for each of these, you may have 1, you may have 2, you may have more. This, though, is how many times things are repeated. And this works really well for our words and how many different orders we can put letters in when letters are repeated. So our first example here says find the number of distinguishable permutations in the letters in even and California. So let's look at the word even first. We'll start with a nice easy one. Even has 4 letters. Oops. So even has 4 letters, of which 1 is repeated 2 times. So this is 4 factorial over our S here. S, remember, is how many times one of the objects is repeated. So we've got one object repeated 2 times. So I'm going to put 2, that's my S sub 1, and I just have to put factorial there. So this is really 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. So those cancel. So this is really 4 times 3, which is just 12. Let's look at B. Now would be a good time to pause it and try it on your own. Okay, the word California has 10 letters, of which A and I, so we've got 2 letters now, A and I are both repeated 2 times. See, A is twice here and I is twice here. So we've got 2 letters repeated 2 times. So my N is 10, so I'm going to do 10 factorial over, I've got 1 letter repeated twice, so I need 2 factorial, and I have another letter repeated twice, so I need 2 factorial again. So this is 10 factorial over 2 factorial times 2 factorial. Well, that's really 10 factorial over, this is 2 times 1 times 2 times 1, which is really just 4. So at this point, I would put 10 factorial divided by 4 in my calculator, which gives you 907,200. So it's kind of a large number to multiply out in our head, so just use our calculator for that one. So here's some more practice, a couple more of these words. Again, I suggest you pause it and try this one on your own. So the word tomorrow here, if you count how many letters, it has 8 letters. It's got 8 letters, and we've got a few repetitions. The letter O is repeated 3 times. And we've got the letter R, and that's repeated 2 times. So let's write this out. I've got 8 factorial, because 8's my N, over, I've got 1 letter repeated 3 times, so 3 factorial. I've got another letter repeated 2 times, so times 2 factorial. So this is 8 factorial over 3 times 2 times 1 times 2 times 1, which is really 8 factorial over 3 times 2 is 6 times 2 again is 12. And if you put that into your calculator, you'll get 3,360. The word yesterday, if you count it out, it's got 9 letters. And we've got a few repetitions here. The letter Y is repeated 2 times. And the letter E is also repeated 2 times. So I've got 9 factorial divided by, I've got 1 letter repeated twice, so 2 factorial, times another letter repeated twice, that's another 2 factorial. So I've got 9 factorial divided by 2 factorial times 2 factorial, which if you simplify this, you'll get 90,720. And that's the end of lesson 10-1. Remember, if you have any questions, make sure you starred them so that we can go over them in class tomorrow, and have a great night.